Okay, so good afternoon, everyone. My name is Asid. I'm the current project lead and some other stuff too. So I take care of a lot of things in the team itself. And this interest meeting is supposed to be introduce my team to new guys and to develop some interest into this team and how you could contribute more in this space. So a little housekeeping notes before we get started. Uh, Keep your questions for the end. We'll open the room for everyone once this session ends, so we can have that ask us anything session with you guys. Uh, these slides have some sort of number associated with them, so if you have some questions, you could like jot it down somewhere. Like slide 3, slide 4 has some questions, something like this, so it becomes easier for me and you to traverse in the ask me anything session. Then just raise your hand when you have a question, so it becomes easier to uh, ask those questions, because quite frankly it becomes really difficult to manage in a room full of 100 people. And keep yourselves muted if you're not speaking anything. And I've been asked to record this, so if you wish to like look back into the slides and the video, uh, you wanted to say something? Okay. uh, this will be available in our Discord server. More news on the Discord server in the later slides. So, who about me? I'm Asif Vora. I'm in my final year of computer engineering, so batch of 2022, and I've been a member since 2019. I take care of recovery and PR management in the team itself. So you can ask me anything regarding different college teams from our college, and I might be able in a position to answer that. Then you can also ask me about different stuff as well regarding college. So I am your senior, so I'm bound to answer those questions for you. And I know a thing or two about rocketry. Not to brag, not to toot my own horns, but that's okay. Okay, a little bit about our team. So we have been uh, we're a student rocketry team, and student run project entirely. And we've got members from all different kinds of engineering discipline into our team that design, builds, tests, and manufactures uh, rockets. Well, that is like the easiest way to put it in. We also have a lot of different teams on campus that make formula vehicles, that make ATVs, that makes unmanned aerial vehicles, that makes drones. We happen to build rockets, so nothing too special about it. It's just another student run project. But yeah, that is a unique selling proposition if you wanted to ask us. uh, we're the only one from Maharashtra, so that has like successful designed and tested our design. uh, and we're like one of the few Indian teams that participate in different competitions. So if you ask me, there are like two ways to put it in. We like I like to describe it. It's rocketry as a competition and rocketry as a research project. More into that later, but that is all you need to know for now. A little history about us. We were one of two teams that participated in intercollegiate rocket engineering competition, or IREC, and the only one successful to launch it till date from Maharashtra. And we have like successfully launched it in our debut flight itself on 2018. Uh, so the videos you guys saw before this, like in the prior session, like the videos that I was playing on YouTube, and that was from IREC. IREC or Spaceport America Cup, they're both the same thing, so don't get confused with that. Uh, let's talk a little bit about rockets itself. When we say rockets, you like picture something like Falcon 9 or GSLV, PSLV, or Ariane 5, and no, we're not in that space, but we're making our upper way over there. So here's a comparison of height comparison on how our design stands in front of all the different flagship rockets. So it's actually a bit smaller than that. It was like kind of embarrassing to put it up in such scale, so I made it a little bigger. But it's smaller than that usually. Like it's like this design that is being marked under this ellipse is around 7 feet tall, and all the different designs are like 2 digits or 3 digits figure tall in feet. So when I say address rockets, I mean sounding rockets over here. So why sounding rockets, and what are sounding rockets, and how do I put it in picture over here? So let's just take a really nice example that I like to use in my induction events. So let's say your mom told you to bring some groceries from the nearby market. सब्जियां लाने बोल दिया तुमको. So what do you do usually? अपनी मतलब प्लेन वगैरह लेके थोड़ी जाओगे वहां पे, या फिर स्कूटी लेके जाओगे, या फिर बहुत ज्यादा हो गया तो गाड़ी लेके जाओगे. सो there's a scale, right? You can take a plane to reach your local market, but is it going to be like really smart option to just go to a local market and on a plane or a helicopter? No, right? And that is where sounding rockets come into picture. So why sounding rockets, and what are sounding rockets? uh, let's say you have prepared an experiment, a scientific experiment that is strategically catered to just go to a certain height target, which is called apogee. So every time you hear me saying apogee, I mean height target. So uh, the design that is being made for specifically for that height target, you will use a smaller design, right? It's being like tailored to just go to that altitude and get back down to earth. That's it. You don't have to orbit everything. So that is why you use sounding rockets. And we design rockets that are strategically going to some certain height target to achieve some sort of goal. We have done it before. We have used different scientific experiments, validated our results, and got back some really great numbers with it. So why these designs? It is simple to make. It's cost effective because, well, not everybody can afford to build a Falcon 9, and it's time efficient. So you can like build it really quickly, and and it's scalable too. I forgot to mention this, but it's scalable too. Now, what makes them so special is that you have the convenience of launching a sounding rocket with payloads ranging from 5 kgs to 50 kgs, depending upon your scientific experiment. And you can literally launch it from any place, if you ask me. Just a cautionary note that you don't launch it from a भरे शहर में तुम इसको लॉन्च नहीं करोगे, कोई अच्छी बड़ी फील्ड से ही लॉन्च करना. So you heard it here first. And it's really quick to make too. Uh, from our perspective, it takes around, on an average, 7 months to completely build a design ground up. And how do I go next? Okay. Let's just talk about the different departments associated with the team. If you're like understood what the team does, what it makes, and why does it make it. Uh, okay, so departments in the team. We have two different departments. It's the technical and the non-technical part. So the technical team takes care of designing the launch vehicle, doing proper computational stuff like analysis, and it makes sure that to document all those things, and it makes sure that it designs the entire rocket itself in just a nutshell. And the non-technical teams make sure that all the requirements set from technical team is fulfilled. So if the technical team asks for something like materials or services, they're going to reach out to the non-technical people and just say, hey, I need this, you get it for me? And the team will be like, yeah, sure, I can get it for you. So these are the two departments. This is further categorized into some other things as well. So in the technical part, it is divided, further divided into these sub teams. So there's the vehicle engineering sub team, there's the propulsion sub team, and the payload sub team. So the vehicle engineering takes care of designing the rocket ground up. Uh, it takes care of doing proper analysis on everything, and it makes sure it gets back in one piece with the recovery team, and it makes sure it has got all the in-flight electronics and computers uh, enabled on it. Then there's your propulsion team that designs the core element, the core fuel of the project, so that it makes sure that your rocket gets off the ground really easily. So the propulsion team takes care of that. And then there's your payload, which is like why you're launching it in the first place. So the payload team makes sure to design your scientific experiments that is going to sit on board your rocket, and make sure to reach your high target and gets back in one piece. First off, we have Aerostructures. Uh, this is more inclined towards mechanical production, chemical engineering people. So, if you're from any of these departments in your discipline, uh, you have a fair good chance of understanding more about this. But still, uh, in our team, we do not impose any restrictions on any kind of department you're from. Uh, if whether you're from any discipline, you're free to join any of the different departments in the team. uh, it's just that aerostructure department happens to be more mechanical intensive, but to design the entire fuselage, to design the internal components, to design the launch infrastructure, and to make sure that it is strong enough so that it comes back down to earth safely. And then there's the analysis team. This is another sub team similar to Aerostructures, whose sole purpose is to uh, make sure all the components that are on the rocket itself is strong enough and aerodynamic enough to sustain the loads of flight. And just there are a lot of moving parts in the rocket, and you need to make sure that they are really strong and has a high degree of uh, factor of safety involved in the design itself. And coming up next, we have the recovery team, which is like one of my favorite sub teams. What this team does is it makes sure that your rocket comes back down in one piece. It's really cool to have being on a propulsion team, making sure it goes off the ground, but it's also important that your design comes back to ground to earth, uh, considering you spend lakhs of rupees designing this. So the recovery sub team makes sure that your design parachutes deploys in time, and it makes sure that it brings down the descent velocity enough to uh, get a soft touchdown and not a hard crash down. So then there's the avionics team. The avionics wait sorry uh, the avionics team makes sure that uh, to design your own flight computers. So the recovery team make sure to deploy the parachute. But how do you deploy the parachute itself? You need to separate the tubes itself. So coming back to this picture over here, you can see these empty spaces in the design itself. These are being vacant for parachutes. And how do you deploy them? You make sure to separate these tubes. You can do this with uh, pyrotechnic methods, like anything that involves fire, or you could like use some sort of mechanical system to eject this. But how does this even work? You have your flight computers. So flight computers uses onboard sensors to detect flight events, like, okay, this has reached the highest point of my journey, I need to deploy one of the chutes. So the onboard sensors on this flight computer detects that and deploys the chutes. And uh, and it's really important. Plus it has got other sensors as well to uh, give us some sort of idea on where a rocket is, like the GPS, and what kind of condition it is in, like different inertial units, like how fast is it coming down, how fast is it going up, uh, all kind of data. So anyone from computer science, IT, anyone from electronics, they can enjoy the liberty of joining this sub team, as it involves a lot of computational design itself. So if you're from any of these backgrounds, we highly encourage you joining this sub team. But still, if anybody from mechanical comes and says मेरे को avionics करना है, we won't stop you. Trust me. Then there's propulsion sub team. The propulsion sub team, uh, right now, I'll tell you in terms of the competition itself. The competition has got two different ideologies. Either you buy your propellant or you design it on your own. So it's commercially off the shelf for buying something, and student research and developed for uh, making your own design ground up. And this is where the propulsion sub team comes to its shine. We have worked with solid propellants before. Like, if you could see this picture clearly, I'll just zoom it a little. Okay, great. I'll bring this to front. Okay. Uh, Over here, you can see all the different kinds of propulsion technologies. You have a chemical propulsion, solid, liquid, hybrid, green propellant, but there's all sorts of different kind of propulsion system as well. There's plasma, there's solar sail, there's nuclear, and there's solar electric propulsion as well that is used for satellites. And what we have worked with before is solid, but we do have a hybrid project coming up. More on that later. So right now, we did work on making our own propellant out of sugar, but we are trying to make different advanced propulsion system as well, so that we could participate in more challenging categories in the competition. We'll talk about competitions later, but let's just uh, assume that you guys know about this, so it becomes handy when I talk about competitions later. Uh, then there's payload sub team. Uh, we have done a lot of interesting things with payload. Trust me, like aged quite a lot just by talking about payload in my team. Uh, we've built deployable unmanned aerial vehicles. So there's one tube, and that tube separates to two, and from that tube, you could deploy a whole aeroplane. So that was our objective for the 2020 mission. But since 2020 didn't happen because of COVID, we shifted to a different particle physics payload. So right now, the design you see in front of you, this is oatmeal. This was what we have been working on for a few months and a year at this point. And what oatmeal does is it detects cosmic background muon date. So if you don't know what muons are, they are basically subatomic particles that are generated from coronal mass ejections from sun. So a lot of jargonish words that I spoke over here, but trust me, it's really easy to understand. Basically, when the cosmic microwave background radiation enters Earth atmosphere, it gets segregated into different subatomic particles. So Higgs boson, then there's muons, there's galvatrons and everything. Uh, and to this device specifically, this detects muons, and this happens to be using a scintillation method. So if you're aware about scintillation, that's great. If you don't, that's like more than enough information for you to digest today. But we did work on different mechanical payloads as well. The one that you see here at the bottom, this is a ferrofluid project, which involved using ferrofluid to damp vibrations from the rocket itself. So when, like I mentioned, your rocket is going to go in some transonic region. So transonic is less than Mach 1 speed, and it will experience a lot of vibration, which isn't shock. So 100 to 200 hertz of vibration, and you have sensitive electronics on board. You need to insulate those vibration in some sort of fashion, and this ferrofluid happens to do the same way. So when the vibration when the vibrations increase, uh, this coil over here, this copper coil, is going to produce some magnetic field, and this magnetic field will then make the inner ferrofluid stiff enough to dampen the vibrations inside of it. So this was a novel idea being used in 2019 competition, and we did get some novel credits out of it. Now, talking about the non-technical team, they handle finances, they handle the operations, marketing, sponsorship, outreach, social media, logistics, everything. So, where the technical sub team
So
make.
your sound is not coming.
You're
Yeah,
muted.
Arshit, I
Your
think
side.
you are
Okay,
mute.
really sorry. Like,
Sir,
I guess you
your
know I
mic
got
is off.
muted. I guess I got muted somewhere. Where was I muted? Like, did you guys hear about the payload part?
Yes,
Yeah,
yeah,
the
we
last.
heard about it just before you were
Yeah,
starting to
Okay.
tell about the PR and management.
Okay, great. So this non-technical team, this PR and management team, make sure that they handle the finances, they handle the operations, the marketing, social media, sponsors, whatever you know it. Uh, and this sub team makes sure that the project does not stop anywhere with and works flawlessly without any hiccups. Uh, so let's just give a brief recap about all the different departments. And the aerostructure analysis team makes sure to design and analyze the launch vehicle. They work on the material selection part of it. They do computational analysis of all the different uh, parts of the rocket, and they work on composites and well fun mechanical and computer stuff. The propulsion team make sure that your rocket gets to the height target as safely as possible, and with all the requirements being gathered by the systems engineering team. Then there's the recovery team. It makes sure that your rocket goes up by the propulsion team, but it comes back down by the recovery team. So there's the recovery sub team. uh, Talking about the avionics, the they build the flight computers overall and all the different softwares needed to monitor the overall status of the flight. And then lastly, there's the payload team, which is the whole reason why you're even flying the rocket. So that was about the different departments in the team. Now we'll talk about the projects right now. So we had two different projects, the competition projects right now, which was the perfect game, which was for Latin American Space Challenge that happened last year. What month was it? I guess November. Yeah, it was November. So this happened in the November month, and different like this was entirely run by the juniors in the team, so there were no senior intervention involved. And then there's our load save project, which is going to participate in the Spaceport America Cup 2022. And we don't have an insignia ready yet, so that is why I have just put up a placeholder image here. So still talking about the perfect game project, which is like one of my favorite things to do in the team. And this was run entirely by juniors. I just happened to just put in my expert commentary in this project and just give some good memes in my Discord server. But yes, overall this was run by the juniors in the team. The key highlights about this okay, wait, before the highlights, let's talk about the competition itself. Latin American Space Challenge was Latin America's biggest rocketry competition, and there were teams coming from 8 different countries. And since this was an all online event, the all the teams were judged in terms of design, implementation, novelty, and overall completeness. And the good thing about this design was it was almost completely student built. So key highlights about this design that you see over here. So this is called Hero, and Hero, like, a really fun story about Hero is that it comes from Attack of Titans. If you have seen Attack on Titans, I think you know where this is going. So this is a half-kilometer height target optimized rocket, uh, which involves a pneumatic based pyro piston for recovery. So where many student teams do is create small explosives explosions in the rocket itself, so you could pressurize some compartments and remove the tubes itself. We used a mechanical system where we involved pneumatic pistons. And okay, I see Tatakai in the chat, that's great. uh, then this is a modular design, so you could just increase the length of the tubes and fit in larger motors so it could achieve different height targets again. Then this is a optimization in the design itself where it could have really less pressure drag overall. So anyone from mechanical background, they know different kinds of drags, and you need to optimize all of them to achieve a greater aerodynamic stability. And this one happens to be really aerodynamic. And in terms of payload, it had a electronics payload that could easily 3D map the entire route of or the journey of the rocket without using any kind of exotic sensors like GPS. So if you wanted to create a 3D plot of your trajectory, you had to use GPS before, but this design did not do it. Uh, and we found some novel ideas out of it to use inertial sensors instead of GPS. And for this, we came in second worldwide in our category and sixth overall in the whole competition, with our design implementation being one of the highest overall in the competition. So this was about the perfect game. Now I do wanted to play this video. Just let me know if you could hear the audio itself. This is really nice video. Highly recommend you guys watch it. I'll also have this link available in my Discord server too, so that you guys could watch it. Uh, let's talk a little bit about Spaceport America Cup. It's the world's largest student rocketry competition. So right now you just saw Latin American Space Stand, that was the largest in Latin America. This one happens to be worldwide, and schools from six different continents participate in this competition, and it takes place in Spaceport America, New Mexico, US. And if it was a flight event, it was 5 days long, and there are six different categories in this entire competition. So that being said, let's talk about the little highlights about this competition. We have been participating for two flight events and one virtual event in this competition, and from what I've heard from my seniors, it's all worth the money you put into this competition, trust me. uh, and you get to learn a lot of things from this competition itself. Since there are schools coming from six different continents, you get to connect a lot of people. So सर हिंदी मध्ये पण एक्सप्लेन करा. Oh, Discord link. You'll get the Discord link at the end of this meeting. And अगर तुम लोग को हिंदी में भी एक्सप्लेनेशन चाहिए तो बहुत अच्छी बात है, मेरे को हिंदी ज़्यादा अच्छा जमता है. तो स्पेसपोर्ट अमेरिका इज़ लाइक सबसे बड़ा कंपटीशन है, रॉकेटरी कंपटीशन है इन टर्म्स ऑफ स्टूडेंट बिल्ड डिज़ाइंस. तो यहाँ पे लाइक 6 कॉन्टिनेंट से लोग आते हैं टू पार्टिसिपेट इन दिस, एंड यहाँ पे 6 कैटेगरीज होती है विथ टू डिफरेंट हाइट टारगेट्स. तो 10,000 फीट अबव ग्राउंड लेवल एंड 30,000 फीट अबव ग्राउंड लेवल. तो ये हाइट टारगेट इज कॉल्ड एपोजी, एंड you have to make designs so that they reach that much high target. वे हैव बिन हम लोग यहाँ पे 10,000 फीट वाली कंपटीशन में पार्टिसिपेट किए हैं, बट वी डू प्लान ऑन गोइंग हायर. बट सिंस कोविड के चक्कर में हम लोग ज़्यादा अच्छे से डेमोन्स्ट्रेट नहीं कर पाए, वी आर गोइंग टू पार्टिसिपेट अगेन इन द 10,000 फीट कैटेगरी. एंड आई होप लाइक दिस वुड बी द लास्ट टाइम, सो दैट हम लोग बाद में और दूसरे कंपेटिटिव हाई टारगेट्स पे पार्टिसिपेट कर सकें. एंड just because 2021 वाला ऑनलाइन गया था, that does not mean it would have been a bust. We made amazing connections across the globe. We have mentors from different countries helping us, supporting us in the project itself, and we have made quite a number of friends that help us, motivate us into bring the best out of us. एंड ओवरऑल बहुत बढ़िया एक्सपीरियंस रहा था अभी तक का. देर इज़ one more event like there's one more project I need to talk about. If you remember, I just said rocketry as a competition and rocketry as a research project. This is it. So there's one more project here, and it's called Hybrid Ambition. Uh, this is something me and other few seniors have been working on, and this involves creating a hybrid liquid engine. तो टॉकिंग अबाउट लिटल अबाउट प्रोपल्शन सिस्टम, अगर थोड़ा टेक्निकल जा रहा होगा, डोंट वरी, यहाँ पे टेक्निकल चीज़ें बहुत अच्छी लगती है लोगों को. सॉलिड में क्या होता है, तुम्हारा फ्यूल और ऑक्सीडाइज़र एक ही जगह मिक्स किया हुआ रहता है. सो just burn it from one end and you'll get your combustion overall in one chamber. Whereas हाइब्रिड में कैसा रहेगा, तुम्हारा सॉलिड फ्यूल रहेगा एंड लिक्विड ऑक्सीडाइजर रहेगा. सो when we talk about propulsion system, especially chemical propulsion, you need to have a fuel and an oxidizer, and this one happens to have solid fuel and liquid oxidizer, and that is why it's called hybrid ambition. A little highlight about this design, it's based on paraffin wax and nitrous oxide, three grain hybrid liquid engine, and combustion chamber being designed to withstand 3000 psi of chamber pressure. And the images that you see is like just a show of concept, बहुत अच्छे से चेंज हो सकती है. दिस इज जस्ट सम इंजीनियरिंग forethought that we put with the experiences that we learned over the years. So this was all about the competitions and the projects that you needed to know. Now we'll talk about the recruitment procedure and perks. यहाँ पे तुम लोग कैसे ज्वाइन कर सकते हो और इसके क्या क्या फ़ायदे होते हैं. तो सबसे पहले तो यू गाइस हैव टू फिल आउट द रिक्रूटमेंट फॉर्म. तो जिन लोगों ने गूगल फॉर्म भरा, वेल एंड गुड. जिन लोगों ने अभी तक नहीं भरा है, प्लीज़ भर लो. अभी भी बोल रहा हूँ, उसके बिना हम लोग को तुम लोग का ये आइडिया में नहीं मिलेगा. तो once this is done, make sure that you guys are in any one of the updates group, and then we move to the exam itself. So this will be really simple exam. तुम लोगों ने भी ऑनलाइन एग्ज़ाम दिए, मैंने भी ऑनलाइन एग्ज़ाम दिया है. सो आई डोंट थिंक दिस शुड बी अ प्रॉब्लम ओवर हियर. बट स्टिल, अगर तुम लोगों को जानना है क्या आता है यहाँ पे, इट विल बी सिंपल फिजिक्स, क्वांट, लॉजिक एंड जनरल अंडरस्टैंडिंग ऑफ थिंग्स. तो लाइक जीके वगैरह हो गया, या फिर सिंपल अंडरस्टैंडिंग वाली चीज़ें हो गई. देन वंस दिस इज़ डन, हम लोग यहाँ से थोड़ी बहुत स्क्रीनिंग चालू कर लेंगे. जिन लोगों का सही में नंबर्स ख़राब रहेंगे, will like trim them off, but जिन लोगों का क्लियर होता है, they'll move to the interview round. You guys have to sit with for an interview with us. It's just that it's just standard procedure. हम लोग सीनियर्स भी करते आ रहे थे और हम लोग भी यही कर रहे हैं. And we wanted to just get to know you better. We just wanted to know कि how our members that are going to join us this semester are like. तो we'll just have general Q&A टाइप ऑफ सेशन इन दिस इंटरव्यू राउंड. हम लोगों को बस जानना है तुम्हारा इंटरेस्ट क्या है, तुम्हारे पास्ट प्रोजेक्ट्स कैसे रहे हैं, हाउ यू गोइंग टू पुट फोर्थ वैल्यू इनटू दिस टीम. यही सारी चीज़ें हम लोग इंटरव्यू राउंड में असेस करेंगे, एंड विल गेट टू नो यू बेटर. एंड देन लास्ट में ये हमारे एंड से ये चीज़ होगी, एप्लीकेशन स्क्रीनिंग. सो वी विल क्रिएट सम पॉइंट्स बेस्ड ऑन द इंटरव्यू इटसेल्फ. तुम्हारा बॉडी लैंग्वेज कैसा था, तुम्हारा ओवरऑल एक्सपीरियंस कैसा रहा है अभी तक इंजीनियरिंग में, एंड हाउ यू गोइंग टू लाइक क्रिएट अ पॉजिटिव एटीट्यूड एंड एनवायरनमेंट अक्रॉस द टीम. सो ये सारी चीज़ें डिस्कस करने के बाद, once we feel like we should have you in, we'll take you in. And like chances are really high, यहाँ के लोग काफ़ी talented होते हैं, so we take them in. And last में जो भी results आएंगे, we'll either post it on social media or we'll just send out emails and everything. Plus I like to make customized invites for everyone, so I'll make sure to email you guys. So ये रहा पूरा प्रोसीजर. यू हैव टू फिल आउट द रिक्रूटमेंट फॉर्म, यू हैव टू क्वालिफाई द एग्ज़ाम. ये एग्ज़ाम कल रहेगा, संडे को, एंड टाइमिंग आई गेस 4 PM है, बट स्टिल मैं तन्मय के साथ एक बार कंफर्म कर लूँगा. तन्मय है क्या यहाँ पे?
Yes, I'm here.
Okay, 4 p.m. right?
Yeah, yeah, 4 p.m.
Okay, so this will be tomorrow 4 p.m. and आफ्टर दिस जैसे ही हम लोग का एग्ज़ाम के रिजल्ट्स वगैरह मिल जाएंगे, विल शेड्यूल इंटरव्यूज, सबके टाइम स्लॉट्स हम लोग अलॉट कर देंगे, एंड देन वंस दिस इंटरव्यू राउंड एंड्स विल स्क्रीन देम अकॉर्डिंग टू आर जजमेंट, एंड देन हमारे ड्यू डिलीजेंस के साथ में रिजल्ट्स भी डिक्लेयर कर देंगे सो दैट वी कैन गेट स्टार्टेड. अभी तक जितना भी हम लोग बात किए, जितनी भी अचीवमेंट्स आई है, लेट्स जस्ट नॉट फॉरगेट अबाउट फेलियर्स ओवरऑल. अचीवमेंट्स सबको सुनना पसंद होता है, फेलियर्स किसी को सुनना पसंद नहीं है. सो लेट्स जस्ट टॉक अ लिटिल बिट अबाउट फेलियर्स इटसेल्फ. I guess this is a video, right? Yeah, this is a video. The video that you see here was our debut flight, APJ 1.0, and it took at 2018 IREC. This was like a successful debut flight, but it did not come down right. So हम लोग को इसको खोजना पड़ता है, एंड वी कुड नॉट फाइंड दिस डिज़ाइन ओवरऑल, लाइक वी कुड नॉट फाइंड दिस रॉकेट ओवरऑल. वहाँ के जितने भी सेफ्टी मेम्बर्स थे, वहाँ पे जितने भी स्टूडेंट एंड टीम्स थी, वो लोग भी बहुत ज़्यादा खोज रहे थे इसको, बट वी कुड नॉट फाइंड दिस डिज़ाइन ओवरऑल. सो RIP APJ 1.0. एंड ओवरऑल ये होते रहता है, ऐसे डिज़ाइन मिसहैप्स होते ही रहता है. सो इट्स इम्पॉर्टेंट टू लर्न फ्रॉम दीज एक्सपीरियंसेस एंड मेक श्योर टू implement it in a better fashion for the next design overall. And this should not be the reason for you to stop, ऐसा मेरे को लगता है. And for this reason no one ये stopped either way. 2018 के बाद 2019 आया, उस पर भी थोड़े बहुत इश्यूज आए थे, उसकी भी रिकवरी बैलिस्टिक हुई थी. मतलब एक ही शूट निकला तो दूसरा वाला इतना ड्रैग प्रोड्यूस किया नहीं जिससे वो सेफली नीचे आ सके, तो उसके काफ़ी सारे पार्ट्स टूट गए थे. अभी भी अगर आप लोग कभी वर्कशॉप आओगे, यू कैन सी ऑल द ब्रोकन रेमनेंट्स ऑफ प्रीवियस डिज़ाइंस, बट स्टिल देर लाइक मेडल्स ऑफ ऑनर टू वेयर प्राउडली, जस्ट टू से डैट कि हाँ, हम लोग ने जितनी भी गलतियाँ की है, एटलीस्ट वी लर्न फ्रॉम देम. देन देर वॉज आवर 2021 ऑनलाइन सेशन. इस पे भी हम लोग के काफ़ी गलतियाँ हुई थी, एंड बट स्टिल वी गॉट टू लर्न अ लॉट ऑफ थिंग्स. एंड देयर इज़ लाइक वन मोर थिंग टू मेंशन. कोविड के चक्कर में बहुत ज़्यादा इश्यूज आई थी टीम में. ओवरऑल टीम के स्ट्रक्चर के फॉर्म में अगर बोलेंगे तो लाइक बहुत ज़्यादा डाउन साइजिंग हुई थी, बट स्टिल we happened to build from concrete itself, and we came back strong, more than stronger than enough. तो this is like a unique selling proposition. कोई भी टाइप का हम लोग का गलती हो सकता है इस पे, बट this shouldn't be the reason for you to stop. And this is like projects like these matter a lot. आप लोग कोई भी इंटरव्यू में बैठोगे, कोई भी अगर ऐसा चीज़ दिखेगा ना, वो लोग बहुत ज़्यादा इम्प्रेस होते हैं. लाइक यू गाइज वर्कड ऑन अ मल्टी डिसिप्लिनरी इंजीनियरिंग प्रोजेक्ट एंड represented India at a global level, which speaks a lot about you. They'll know कि you have gone through some serious shit, and that is why you happen to be more than confident and enough. And इट्स जस्ट मैं तुम लोग को एक एक्सपीरियंस दे रहा हूँ. मैं कोई भी ऐसे इंटरव्यू में बैठता हूँ, एंड व्हेन दे सी कि आई हैव वर्कड ऑन दिस रॉकेटरी प्रोजेक्ट, and they ask me why you mentioned this here, you're coming for an IT interview and you happen to mention this. I just say I boast a lot about research skill that I learned from this project itself. मेरी रिसर्च स्किल्स इतनी ज़्यादा डेवलप हुई है, पूछो मत. दैट research skills in the sense कि if someone hands me a task, I know where to start and I know where to make out information from, so that उस information को मैं अपने हिसाब से चैनलाइज करूँ और अपने हिसाब से खुद को सिखा सकूँ. एंड दैट इज़ वाई रिसर्च स्किल्स आर इम्पॉर्टेंट. सो नेक्स्ट टाइम अगर कोई भी IT इंटरव्यू में ये पूछेगा कि आप क्यों ऐसे टीम में थे और क्या सीखे वगैरह वगैरह, एंड इफ़ यू आर अ मेंबर, make sure to use this point. You heard it here first, and make sure to give me good credit for it. So, what are the different perks of joining this team? First off, you have to look at the big picture, and you'll you'll see a lot of things more vividly than ever. नेक्स्ट टाइम कोई भी इंजीनियरिंग डिज़ाइन को देखोगे, यू विल स्टार्ट इमेजिनिंग थिंग्स कि अरे भाई इसकी गियर इतनी मोटी क्यों है, इतनी पतली क्यों है, इसका फैक्टर ऑफ सेफ्टी तो इतना बढ़िया रहेगा, इसकी डिज़ाइंस देखो कितनी अच्छी है, अरे इन लोगों ने तो रेस्ट एपीआई वगैरह यूज़ की है. सो you get to see a lot of things in finer detail, and that is like one of the key advantages working here. You get to influence STEM culture amongst your peers. This is why we do these things, to boost STEM influence. So if you don't know what STEM is, it stands for science, technology, engineering, and mathematics. And this is a really popular culture in the states, not so much here in India, because यहाँ के लोगों को इंजीनियरिंग स्टूडेंट्स के ऊपर मीम्स बनाने बहुत पसंद है, जबकि वो लोग खुद 8वीं फेल है, बट स्टिल. Then there's international exposure. You get to meet a ton of talented people across the globe, and you get to learn a lot from them. उनकी कल्चर इतनी डाइवर्स होती है, they'll make sure to uh, get influence in this field quite a lot, and that is like maybe one of the reasons why I stuck for so long. Then understanding industrial requirements. Once you start working here, it's important to know what you're getting into, and once you start working on some projects like this, तुम लोगों को पता चलेगा कि क्या क्या चीज़ें लगती है इसमें बनाने के लिए. लाइक मैकेनिकल पर्सपेक्टिव से बोलो, इलेक्ट्रॉनिक्स पर्सपेक्टिव से बोलो, कंप्यूटर के पर्सपेक्टिव में बोलो, और ओवरऑल नॉन टेक्निकल स्टफ के हिसाब से भी सोचो तो you'll know what are the industrial requirements for these kind of projects. Plus, fifth one, you guys are here to learn all these things, so you'll will make sure you'll have a time of your life. तुम लोग ओवरसीज अपनी ट्रिप्स करोगे, तुम लोग दूसरे लोगों से मिलोगे, तुम लोग अपने साथ ग्रुप कोलैबोरेशंस करोगे, अलग अलग कॉलेजेस के साथ मिलना जुलना होगा, अलग अलग कंपनीज के साथ मिलना जुलना होगा. सो रॉकेट्स आर कूल, बट इट्स इवन बेटर व्हेन यू हैव गुड कंपनी. तुम्हारे साथ अच्छे लोग आएंगे तो तुम खुद अपने हिसाब से प्रोग्रेस कर पाओगे. एंड एवरीथिंग यू लर्न हियर डज नॉट गो इन वेस्ट. हम लोग के साथ में बहुत लोग ऐसे भी होते हैं कि वो लोग छोड़ के चले जाते हैं, बट स्टिल दे लर्न अ ट्रेमेंडस अमाउंट ऑफ नॉलेज इन द टीम इटसेल्फ. वो लोग आगे जाके दूसरी दूसरी चीज़ें करते हैं, वो लोग अपने स्टार्टअप्स कर लेते हैं, वो लोग दूसरे टीम्स को ज्वाइन कर लेते हैं, वो लोग अपना कुछ फ्रीलांस करते हैं. सो दे लर्न अ लॉट ऑफ थिंग्स ओवर हियर, and they happen to just apply this knowledge in some other way as well. So no knowledge goes into waste when you join the team. And lastly, हम लोग experts नहीं है. First of all, we're just rocket enthusiasts that want to share this knowledge with you guys. मेरे को बस थोड़ी बहुत चीज़ें आती है, तन्मय को थोड़ी बहुत चीज़ें आती है, पीयूषा को थोड़ी बहुत चीज़ें आती है. By the way, these guys are our members, and we just wanted to share this information as much as possible with you guys. So you guys must be wondering what's the next big step on the team itself. Wait, I'll just make this a little bigger. We'll add a Google form over here, and that will contain our Discord server invite over there. Tanmay, if you could just post that Google form here in chat, that would be great. Once you are in, you can like just see how the different teams in the like different sub team members interacted or shared information or like talked over there. तो text channels open ही रहेंगे सबके लिए, सब लोग देख सकते हैं. एंड ओवरऑल क्या क्या रिसोर्सेज हम लोग देखते हैं, किस तरह की डिज़ाइंस बनाते हैं, यू आर फ्री टू व्यू ऑल ऑफ दोज थिंग्स. अगर तुम लोगों को लगता है कि इन लोग का देख के हम लोग अपना खुद का भी चालू कर सकते हैं, वी वॉन्ट स्टॉप यू. You guys are like free to do so, but still if you feel कि ये लोग कुछ ऐसे नया फोड़ रहे, कुछ नया ही अच्छा चीज़ कर रहे हैं, and we should be a part of it, there's always a good cause open for everyone, and you can always be a member. Then be ready for enormous amount of meets and zooms. Then this is not just related to you guys, this is for us as well. तो हम लोग दोनों की चीज़ें यहाँ पे आ जाएंगी. Then there's once all the new members are in, we'll make sure to train you in some way. So once you are in, we'll make sure to have a dedicated program for you guys, so that you could understand rocketry in even greater depth, and that will be tailor made for you guys only, specifically for you guys. For us, we have to prepare a critical design report for the load safe project. We have to do our manufacturing trials. This involves 3D printing, composites, everything. And then there's preparing the IREC guest list, the people that will be going to USA. And that is pretty much it for this presentation. I hope you guys understood in some sense what we do, but if you don't, we'll have our AMA session ready. So thank you so much for joining today. If you have any questions right now, we are open for questions today.